Hi, welcome to Catia V5 video tutorial. I want to do the flexible hose, which I did a while ago in NX. Therefore I have to do some preparations. Okay, let's start with some points. I need a point 1, which is at 0, 0, 0, and okay. Another one, which is at 0, 0, 500. Then I need a line which goes from point 1 to point 2, and okay. Let's turn this a little bit, okay. Then I need a sketch. I use a positioned one on this plane, maybe swap H and V and reverse H, okay. Hide the yellow projected elements, and then I need a spline, something like this, okay. And this point should be aligned coincident with the y-axis, so let's make coincident. Okay, nice. Then I need a law, therefore I need a formula. So I go to FOG, call this flex hose law, confirm, okay. And therefore I need some formal parameters. There's a difference between formal parameters and user parameters, so take care. I want a new one of the type angle, that's okay. Just call this A. And another one, type should be length. So go to yeah. You have to move it over here so you can go to length and new parameter, and this should be X. Then I want to create a formula. X should equal cosinus of A multiplied with, let's say, 80 multiplied with 10 millimeters multiplied with 500 millimeters, and I want to divide it by the length of the spline, so I will close this for once. Doesn't matter right now, it's right here, and I need the length of this spline, so I go for this one, keep the measure, and okay, and maybe hide it. Okay, so go back to my law. It should be divided by this length, okay, and then I want to add, let's say, 20 millimeters. If you don't understand this formula, you will see. Just wait. Okay, this should work. So if you ever wondered how to create a cosinus curve or sinus curve right here in Catia, check it out. Go for parallel curve, give it a reference curve, that's the line, and then give it a law. The support should be maybe this plane. Go for law, pick this one, close, and okay, and there you got it. So now for my flexible hose, I want to do a circular sweep So go for sweep, circular one, center and radius, that's the center curve and the spine, and the radius should be controlled by a law, and that's the law right here. Close, okay, okay, nice. So if you now change this sketch, yeah, you have to take care that it's possible, maybe for like this, leave the sketch and it will change. So maybe I could use some more user parameters to control this hose. Now let's add some user parameters. So go for fx. I want to have one which is sort of a frequency, and it should be of real type, and I just call this f and change it to 80, because if you want to put in some parameters you should always use the values which are actually present in the model. And maybe another one which I call d like diameter, and this should be 20, and apply and OK. So now where to substitute these parameters for the real values? I go to my law, okay, and I want to substitute the 80 with the f, and this 20 millimeters right here with d plus, not plus, but you have to multiply it with 1 millimeter, so your units are okay. Okay, so the model shouldn't change. It didn't change. So if I change this frequency, let's say to 120, confirm, see, you got more of these elevations. And if you change this one maybe to 30, it should get bigger. See? Okay, now I got these two user parameters which are not identical to formal parameters. There's a difference. Yeah, I got formal parameters right here, and I got my user parameters. So maybe change this back to 20, and if you change the sketch, maybe make it a little bit longer. Okay, so hope you enjoyed this one. It's a little bit more complicated as usual, but see you to the next one. Bye bye.